Hello and welcome to the practical on transcranial electrical stimulation. I'm going to talk you through running a TES experiment on one of your participants, how you set them up, and the sort of things that you check for to make sure that you're going to stimulate correctly and record good data. It's important to remember the difference between brain stimulation techniques and neuroimaging like EEG techniques is that the brain stimulation machine isn't actually recording any data for you. You are changing a brain state and observing a change in behavior. So this time we don't have the opportunity that you have with EEG, which is to check that the recording itself is good. Rather, we're reliant upon procedure and good practice techniques. Okay. So we have Mario here again, our substitute participant. Due to social distancing, we're not using real participants. That's why we're not in a lab. And I have our TES, or our transcranial electrical stimulator here. So the TES is really rather straightforward. It is just a battery that can be controlled rather simplistically. One of my favorite components of the TES machine is this little analog slide at the back. This hole over here is where you plug in the TES in order to charge it. These holes over here allow you to plug in the electrodes in order to stimulate somebody's brain. But because of this slide, you'll see that it's not possible to plug in both the electrodes and the mains at the same time. And this, in effect, is a very simple way of forcing you not to stimulate while the mains are plugged in as well, because of course that could be quite dangerous. Okay, before I switch the machine on, I'm going to invite my participant in the lab, who I've gone through the appropriate safety checks. I'm sure that they don't suffer from epilepsy. I'm sure that they don't have a pacemaker. And of course, they've consented to take part. They know exactly what's expected of them. Akin to what you do with EEG, one of the first things you will do is measure the head. But in this situation, you're not measuring the head to determine the size of the cap. There are no caps, or there are rarely the use of caps in transcranial electrical stimulation. Some setups, some more contemporary, some more modern setups, will use a cap with electrodes embedded within them. But usually within TES, you want the flexibility of being able to place just the one or two electrodes wherever you want on the scalp. So in this imagined protocol, I'm going to want to locate the position of the electrodes on the scalp. And in this case, I'm going to place them over the primary motor cortex bilaterally. I'm going to place them over electrode position C3 and electrode position C4, a common experimental setup. Right? So the first thing I would do is measure, just like you do in EEG, from the nasal dip all the way back to the inion, the bump of the head, and locate CZ, which is halfway from the inion to the nasal dip. So usefully enough, it's right where that little hook is. And also I'd measure ear to ear, again, to locate the position of CZ right in the middle of the head. I then know that C3 and C4 is 20% of the distance from between the ears to the left and to the right. To the left for C3 and to the right for C4. I would typically then take a marker, usually a soft crayon marker, and mark the surface of the scalp. That allows me to remember exactly where it is I need to place the electrodes. Okay, once I've identified the location of where I want to place the electrodes on the scalp, I need to prepare my electrodes and prepare the TES machine. So to do that, I have a saline mix. So in this tub of water is a mixture of water and salt, potassium chloride or sodium chloride. Usually potassium chloride is used because it's slightly less corrosive. And I will take these sponges and soak them in the saline solution, being as careful as possible to to saturate them with the saline solution. Saline solution, salty water, will facilitate the conduction of electricity through these sponges. If they're dry, current will not flow through these as easily. I can then take my electrodes. Now you'll see the electrodes here used for TES look quite different to what we were using for EEG. They're usually made out of rubber with an AGCL mesh on the inside of them, but this is conductive rubber. It allows for the electricity to flow through it. You can see, if you look kind of closely, I think the wire mesh embedded in these electrodes. There's a kind of curvature. I'm not sure if you can see that. And these are, and of course, the main difference between these electrodes and those that we use in EEG is that they are much bigger. These are 5 centimeters by 7 centimeters wide. And the reason for that is, of course, is that if we use small electrodes to administer a current to the scalp, we will deliver a high current density, and a high current density is likely to hurt and burn the skin. So we distribute the current that we want to administer to the scalp, and hopefully to the brain as well, over a larger surface area. In doing so, we reduce the current density and reduce the likelihood of harm. We then quite simply place the electrodes inside the sponges that have been soaked in a saline solution. Critically, we have to remember the location of where the wire is placed into, because on these electrodes, and many like them, the location where the wire is placed into the electrode is risen. If this were to be placed onto the surface of the scalp, that would make the distribution of current uneven, and it means that it would be more likely to cause damage or slightly burn the surface of the skin. So importantly, we have to make sure the flat end of the electrode is the one that makes contact with the scalp. Do that with both the electrodes. Now, this is not a universal approach. There are many labs that will use different ways of attaching the electrodes to the surface of the scalp, and some may use a gel, a slightly different gel to what we typically use in EEG, but a thick paste. When you use a thick paste gel rather than a sponge, you wouldn't place the electrode inside a sponge, and rather you'd attach that electrode directly to the surface of the scalp with a lot of gel on it. There are also different ways in which you might want to connect these electrodes to the surface of the scalp, but in this case, I'm just going to use these rubber bands to strap them tightly to the scalp. Okay, so now I am going to place my electrodes on the surface of the scalp in locations C3 and C4, making sure that the flat edge is what's placed on the scalp and not the raised bump. This bit gets quite tricky with a real participant. I'm then going to just use these rubber bands that have holes in them, much like a belt, I haven't done this in a while. So I'm just going to then gently place this round the chin of the participant and tightly kind of strap them in place. Now, you can imagine lots of difficulties in using other electrode positions. You may want to place one electrode slightly more frontally and the other one slightly more posterior. And in doing so, that often doesn't become as easy to strap to the surface of the scalp as I've just shown you if you wanted to stimulate at location C3 and C4. And so often we'll use a variety of different kind of straps, sometimes even swim caps, in order to tightly hold the electrodes close to the surface of the scalp. And effectively, depending on the position of where you want to place these electrodes, you can do all manner of sort of strapping the electrodes to the surface of the scalp and wrapping it around the participant's head in order to best try and connect the electrodes with the surface of the scalp. Right, so now the electrodes are safely attached to the participant, you want to attach the TES machine. So on one end of the wires you have a metal pin, and that quite simply slides in to the hole in the electrode, to the connector in the electrode. And you have another one that connects here. Now the colors, blue and red, are nominally for anodal and cathodal stimulation, with the red usually anodal and the blue typically cathodal, but there's nothing, of course, to stop you switching them round. Once you've plugged the electrodes in to the electrodes on the scalp, you take the wires and you plug them in to the TES machine. Your participant is then ready to be stimulated and engage in a task. Typically, at this point, you'd check that they were okay and still comfortable to continue, because brain stimulation is a little bit more invasive than just neuroimaging. One thing I wanted to point out before I continue to using the machine is that typically you would try and make sure that there is an even distribution of contact of the electrodes across the surface of the scalp. Because if you have one area that's more strongly pressed into the surface of the scalp, the connection there will be better and you will have a higher density of current flow there. It might be a little less comfortable if that were the case. Right, so let's say we have our nice even connection with the electrodes on the surface of the scalp. They're now plugged in. We want to switch on our machine. It's a very simple machine, very straightforward to operate. There are not many settings to use. It always warns you there is, of course, a risk, even with low amplitude stimulation, to damaging tissue. Now, this is although it's called a DC stimulator plus, this stimulator actually allows for direct current stimulation, alternating current stimulation, and also random noise stimulation. And there are multiple parameters that we can set in order to let us do that. The specific jargon that's used for this machine isn't necessary to fully understand. But for now, I'll just set it to TDCS, so you get a broad idea of how to do a straightforward TDCS stimulation. So we have a direct current, so that means that the blue is the cathode and the red is the anode. We can change the current. It's now set at 2,000 microamps. That's just 2 milliamps, or rather 2 amps, sorry. We can change that current. We can move it up and down as we choose. We're going to leave it at 2,000 microamps. We can then change the fade out or the fade in. That's the amount of time that the TDCS stimulator will take to go from 0 to the maximum current that you set it at. Typically, I would leave that almost as high as possible, allow for perhaps, oh no, not quite as high as possible, but you might want to allow for a 40-second or 20-second fade in, so that the current doesn't turn on so quickly that it would hurt the participant or will cause a noticeable change. Let's leave it at 40-second fade in. The fade out is less important, but some people have reported being able to sense it more when it's quickly switched off. So we will also change the fade out to 40 seconds. I've gone the wrong way. Never mind. We'll get there. There we go. Right, so we've now got a fade in and a fade out of 40 seconds. That means the current will slowly ramp up and ramp off when the stimulation is finished. We will, of course, change the duration of the stimulation. We're probably going to go for a few minutes. So let's go up to 600 seconds, 10-minute stimulation. Great. see what other parameters we have. Fade in, fade out, current, duration. That's everything we need. All right. We are now ready to stimulate. And so we go up to parameter and move across. It just shows you the parameters that you've set to make sure that you're ready and keen to start the stimulation. As soon as you're ready to start the stimulation, you press yes. Again, probably a final check-in with your participant before you do so. And I can, in fact, start the stimulation here because there is a safety check in place. If the resistance between the scalp and the electrodes is too high, then the voltage delivered would be dangerous. And so the stimulator won't allow us to continue. So I'll just switch it on, and you'll see it's checking impedance. Apparently the impedance is fine. So apparently my connection between my my Mario here, the rubber scalp, the connection between the rubber scalp and the electrodes is good enough to stimulate, but it's actually quickly reached its limit. So it's not like normal scalp tissue where the impedance would remain low. Okay, so after you've completed a brain stimulation task, you would obviously start the stimulation, and typically you would get a participant to engage in a behavioral task while the stimulation is happening. Sometimes in other settings you would perhaps stimulate first and then ask them to do a task afterwards. Typically after your experimental session is finished, you would check in with the participant. Many studies now require that you ask them about how they're feeling, whether they noticed any particular sensations, if they're experiencing a headache, and if they report any negative feelings or negative symptoms, you would typically ask them to stay in the lab until those subsided. And if they didn't subside, you might need to contact a medical professional, although this is very, very rare and very, very unusual. So usually they're quite happy. You take the device off them, you thank them for their time, and you let them go. All right.